Imagine being given one impossible mission: visit every planet in the solar system and survive for as long as possible. Earth does not count, and you are not getting a magical, indestructible suit. You have advanced life support, radiation shielding, and a spacecraft built for extreme conditions. But the laws of physics still apply. By the end, we will rank the planet where you could last the longest, and the one that would end the mission almost immediately. There is also one major problem. On 4 of these planets, there is no actual surface to land on. Your first stop is Mercury, the smallest planet and the closest one to the Sun. As you approach, the Sun would look more than 3 times larger than it does from Earth, and the sunlight could be up to 7 times brighter. The surface below would resemble a battered gray moon covered in craters, cliffs, and ancient impact scars. Landing is possible, but choosing when and where to touch down is the real challenge. On the sunlit side, temperatures can reach about 430 degrees Celsius. On the night side, they can fall to around minus 180. Mercury has almost no atmosphere to spread heat around, so the difference between light and darkness is extreme. You might aim for the line between day and night, but that line slowly moves. One sunrise to the next takes 176 Earth days, so the sun crawls across the sky without staying frozen in place. Even in a carefully selected area, you would face a vacuum, intense radiation, blinding sunlight, and absolutely no breathable air. Mercury might not kill you instantly while your spacecraft and suit were working, but one thermal failure would turn the landing site into either an oven or a freezer. Surprisingly, though, Mercury is nowhere near the worst destination on this journey. Next is Venus, and this is where the mission becomes horrifying. Venus is often called Earth's twin because it is nearly the same size and has similar gravity. From a distance, it may even look calm beneath smooth, yellow-white clouds. Those clouds contain sulfuric acid, but the biggest threats are waiting below them. As your spacecraft descends, the atmosphere becomes thicker, hotter, and darker. At the ground, the temperature is about 467 degrees Celsius, hot enough to melt lead. The pressure is roughly 93 times sea level pressure on Earth, similar to being almost a kilometer underwater. Your vehicle would need to function like a submarine inside an industrial furnace. The atmosphere is mostly carbon dioxide, and the thick clouds leave the volcanic landscape covered in dim, hazy light. The sulfuric acid droplets are mainly higher in the clouds, so they would not be the first thing to kill you at the surface. The heat and pressure would destroy ordinary equipment first. Even robotic landers built specifically for Venus have survived for limited periods. A person wearing anything resembling a modern spacesuit would have almost no chance. Venus looks like Earth from space, but at ground level, it is probably the most immediately hostile rocky planet. Then you reach Mars, the planet that gives you the first real chance. During a warm afternoon near the equator, the temperature can briefly climb to around 20 degrees Celsius. Gravity is only about 38% of Earth's, so every step feels lighter. And unlike the planets coming later, Mars has solid ground. For a moment, it might almost seem comfortable. That illusion disappears the second your suit fails. Mars has an extremely thin atmosphere made mostly of carbon dioxide. With surface pressure less than 1% of Earth's, there is no breathable air, very little protection from radiation, and temperatures can drop as low as minus 153 degrees Celsius. Dust is another serious problem. Martian winds do not push with the same force as winds on Earth because the atmosphere is so thin. However, they can still lift abrasive dust, cover solar panels, damage exposed machinery, and sometimes darken large portions of the planet for weeks. With a pressurized habitat, reliable power, water recycling, radiation shielding, and replacement parts, humans could potentially remain on Mars for a long time. Without that support, survival would last only as long as the pressure and oxygen remaining in your suit. So far, Mars easily takes first place. But from this point forward, the rules completely change. Because the next four planets have no solid ground. Jupiter is the largest planet in the solar system, but there is nowhere on it to land. What looks like a surface is only the top of an atmosphere that continues for thousands of kilometers. Long before reaching the visible clouds, Jupiter's powerful radiation belts could damage your spacecraft's electronics and expose you to a dangerous amount of radiation. Assuming your shielding survives, you would enter the atmosphere at an enormous speed and begin falling through clouds containing ammonia ice. Near the cloud tops, temperatures are around minus 145 degrees Celsius, winds move at hundreds of kilometers per hour, and gravity is roughly 2.5 times stronger than Earth's. You would suddenly become much heavier, while being thrown through a sky with no ground beneath it. As you fell, the darkness, pressure, and temperature would all increase. NASA's Galileo probe transmitted information for only 58 minutes before it stopped communicating. By that point, it had fallen about 180 kilometers below its entry level and reached pressure more than 22 times greater than Earth's sea level pressure. Far deeper inside Jupiter, hydrogen would stop behaving like an ordinary gas. It would become a hot, dense fluid before eventually transforming into metallic hydrogen, a strange form of hydrogen that acts more like an electrically conducting metal. You would never reach a place where you could stand. You would simply keep falling until the pressure crushed your spacecraft and the heat destroyed whatever remained. Saturn may look gentler, but it offers the same deadly trick. Its rings are made from countless pieces of ice and rock, creating one of the most beautiful sights in the solar system. A carefully planned spacecraft could avoid the thickest parts of the rings, but once you reached Saturn itself, you would discover that it also has no solid surface. At the cloud tops, gravity would feel surprisingly close to Earth's. That might sound encouraging until winds near Saturn's equator begin blasting past you at around 1,800 kilometers per hour. Near the North Pole, a six-sided jet stream surrounds a massive rotating storm. This strange hexagon is wider than two Earths placed side by side and has remained visible for decades. Entering Saturn's atmosphere would send you through layers of hydrogen, helium, ammonia clouds, violent winds, and rapidly rising pressure. Eventually, the gases around you would be squeezed into liquid. Deeper down, the temperature would become high enough to melt and vaporize a spacecraft. Saturn's extremely low average density has inspired the claim that the planet could float if someone found an ocean large enough. But that does not mean Saturn would feel soft or safe. There is no ocean-like surface, no place to stand, and no point where your fall ends peacefully. Uranus is farther away, darker, and much stranger. It rotates on its side almost as though something knocked the entire planet over. One day lasts only about 17 Earth hours, and its atmosphere contains hydrogen, helium, and methane. That methane helps create its pale blue-green appearance, but the atmosphere would be completely unbreathable. The outer atmosphere can fall to around minus 224 degrees Celsius, making parts of Uranus colder than anywhere on any other planet. Winds can approach 900 kilometers per hour, throwing you through an atmosphere filled with freezing gases and ice particles. As you descended, you would move from those freezing outer layers into denser material containing water, methane, and ammonia under enormous pressure. Scientists believe conditions deep inside Uranus may force carbon atoms into solid crystals, possibly creating a form of diamond rain. However, no spacecraft has directly watched this happen. The farther you fall, the stranger the material becomes. The The freezing planet above gradually turns into a hot, dense interior below. Once again, there is no solid surface waiting for you. Uranus would freeze you near the outside and crush or cook you farther inside. Your final stop is Neptune, the farthest planet from the Sun. At that distance, daylight would resemble dim twilight on Earth. Neptune appears calm and blue from space, but that appearance is completely misleading. Neptune has the fastest winds measured on any planet. Some blast through its atmosphere at more than 2,000 kilometers per hour, faster than the speed of sound on Earth. Like Uranus, Neptune is an ice giant with no true surface. Its upper atmosphere is bitterly cold, but internal heat rising from inside the planet helps power enormous storms and extremely active weather. As you sank through the blue clouds, methane, hydrogen, and helium would give way to hotter and denser fluids. Scientists believe diamond rain may occur here as well, but you would never survive long enough to collect any of it. Pressure would crush your spacecraft long before you reach the rocky core. Neptune and Uranus may look like twins, but Neptune is the more active and wind-whipped of the two. On the final planet of your journey, you would be blasted by supersonic winds before beginning another endless fall into heat, pressure, and darkness. So where would you survive the longest? Mars wins by a huge margin. It is freezing, irradiated, dusty, and practically airless from a human point of view. But it has solid ground and environmental conditions that technology could realistically manage. Mercury comes next, but only with excellent thermal control and a carefully selected landing region. Venus would destroy a surface mission through its incredible heat and pressure, while Jupiter, Saturn, Uranus, and Neptune cannot truly be landed on at all. On those four worlds, your landing would become a one-way fall into darkness. The strangest part is that some of the best destinations for future human exploration may not be planets. Moons, such as Titan, Europa, and Callisto, offer completely different environments, dangers, and possibilities. Which moon should we try to survive on first?